Who can tell me why they think Diego is right or wrong with the Y? With the Y. Brandon, what do you think?
Diego is wrong because you don't add exponents unless you're multiplying.
Yeah, so there's no multiplying the exponents here, right? We're adding two different things. The order of operations would require our multiplication to happen first. So, reason one, he's wrong. We can't add exponents in this situation. It's almost like he must have memorized a rule or something and mismemorized it. But what about this part? Let's take the powers of 10 off it. He added these together. Can we do that? Ivy?
Again, the order of operations, you do
Okay, I'm going to ask you this. What about 5x plus 2x? So they're separated by addition, but can I combine these things?
Yeah.
Okay. So there's ways I can still add things sometimes.
Would this be?
So can I add these, is the question. You're still no? Okay, so you're actually correct in the no. We're just not correct with the y yet. Who thinks they know why we can't add these together? Yeah, right?
They're adding the distances and not multiplying them.
No, we can add distances though here. So why can't I add them in this case is what I'm asking. Zeph?
Because, like, the whole problem, like, when you're adding the, 4.7 times
10 to the fourth.
yeah, that is, like, you put both of those in parentheses and then add those two different sections together.
Okay, so let's look at Claire.
So you
Let's
can't add.
let's look at Claire. Claire added things together and got the same answer as Kieran. How did Claire do it? And maybe instead of saying why can't Diego do it, how did Claire make it happen to get the same answer, Ivy?
She changed them to the same.
She changed, so just like my 4x plus 2x is 6x, she's saying 12 of these and 16.7 of these. Wait, no, I did the wrong thing. 4.7 of these and 12 of these equals 16.7 of these. So what's really important to recognize here is in scientific notation, our first numbers are always in the ones digit, right? Pretty much. All of our factors of 10 are held with the 10. So we can't just add up those numbers because, as you see in Kieran's, to add up rational numbers, we need to line up with their place value. And if our scientific notation has a different factor of 10, different power of 10, they're not going to line up by place value if we just add the numbers together. Are you guys seeing that? But down here where Claire says, she changes that 1.2 to 12, now that we have the same number of factors of 10, we line those up by place value, 12 plus 4.7, right? To get that 16.7. Look where the numbers line up. They line up the same once we get the same number of factors of 10. So big picture, the real big picture, if you ever get confused today, to add numbers in scientific notation, we need to line up by place value. And how do we ensure that with scientific notation? Same number of factors of 10. Up here, they're off by a digit. It'd be like saying 12 plus 1.2 is 2.4. You are like, no, that'd be silly, Mr. Mack. It'd have to be 13.2, right? But these aren't lined up by place value. Diego did not line up by place value either. Dang it, Diego. We're going to apply this now, okay? Now that we know to add scientific notation numbers, we need to line up by the decimal. You are going to approach problems 1 and 2, where you're looking at distances and diameters and answering the questions about some of these planets in our solar system. So for number 1, what I need to add, Mercury, whoops, wrong thing. When I need to add Mercury, Venus, and Earth, and Mars, we're talking distance from the sun column. What exponent do I want all my, which one do I want them to have all for my factors of 10?
5.
Huh? I don't want 5. I've got all of these that have 8.
How come?
Because that's what it is. 1 times 0.0. So if I have to change a place value, which one should I mess with? I should mess with mercury. So I know I want it to be times 10 to the 8th. Okay. So if I have another factor of 10 on the right side, I need one less factor of 10 on the left side. So that'd be 0.579 times 10 to the 8th. Would be the same value. All I did was I housed my... Yeah, because I have this many factors of 10 to the 8th, this many, this many, this many, this many. So did somebody add up all of the first numbers here for me? For something like 5-point stuff? Nobody had those up?
It was 5.409.
865409, isn't that something? Times 10 to the 8th. So that is the diameter of all those planets put together. In order to add them up, I needed to line them up by the same place value, because that's how we add numbers. We line them up by place value. And that gives me 5.409 times 10 to the 8th. Compared to Jupiter, is that bigger or smaller?
It is smaller.
It is smaller by 2 times 10 to the 8th. Actually, by like 2.5 times 10 to the 8th. That's kind of crazy, right? All those other planets,
Don't even compare.
if you add up their distances,
Don't even compare to Jupiter.
Jupiter is further away from the sun than all of them add together. That's kind of cool, huh? Is everybody good with how I got these things to line up so I could just add them?
The easiest thing.
So this is, the whole point of this was to make it easier. If we wrote these expanded,
Time for number 2.
it'd be a problem. You guys want some time to try number 2 on your own? Okay. Cam over here. Cam, what did you say we're going to try to get all of our exponents to be, Cam? 4? I like 4 as well, because these two are already there. So for Mercury to have a 10 to the 4th, here's how. Has anybody found like it's a little challenging to see if they increase their 10 or decrease it? Has anybody found that a little challenging at all? No? A little bit. So here's kind of what I do. I know if I'm going to put an extra factor of 10 on the right, I got to lose a factor of 10 on the left. So I rewrite Mercury as losing a factor of 10, but it still needs to be there. So that would have to go 10 to the 4th. That's kind of how I think about it. So 10 to the 4th, 10 to the 4th. So for Mars, again, I need to increase it. So I need to decrease 6785 times 10 to the 4th. And then Jupiter, I need to get rid of one of these factors of 10 by putting it over here. So it's 14.28 times 10. Which one did I miss on Mercury? Oh, 4878. Thank you for bringing that up. 0.4878. Okay. So Vinny and I were having a good discussion here too. He said, can we add up the exponents?
No.
And that we do that when we do what operation with them?
Addition.
We add them when we have what operation with them? Sometimes division when there's the negatives. When we multiply, so really what this is saying is like we have 0.4878 of these. We have 1.21 of these. So we can just add up our first numbers. And if you think back to the number line, remember all the tick marks kept our same exponent? So I know my answer here is going to be something times 10 to the 4th. And how many of those 10 to the 4ths do I have? Who added all those up? What'd you get, Ivy?
17.93623.
Oh, wait, that's actually what I
No,
know.
3.
Yeah, I got that.
93623?
9363.
9363. So, I want to write this in scientific notation. So, I'm going to use one less factor of 10 on the left, so I need one more factor of 10 on the right. Now I can compare this to Jupiter. This is harder to compare to this. Did you guys notice that? Because this is to the 4th, this is to the 5th. So once I have them both as 10 to the 5th, which one has wider? Oh no, I'm sorry. I'm comparing to the sun. Okay. So what's wider? The sun. About how many times wider is the sun?
About 8.
I'm just going to say this and this are relatively close. So about 10 times bigger. So 10 suns would fit in there. Something like that. Maybe something like that. Is that about 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Close enough, right, Ava? Just for framing this number 2, we're going to assume that there are 1 million ants on this farm, okay? So we all working with the same numbers. 1 million ants on this farm. So let's take a look at this farm again. Let me make some room down here to write quick. And so we have a cow, which is 4 times 10 squared. We have 2 sheep, which is 2 times 2, 6 times 10 to the first. We have 3 chickens, which is 3 times 2 times 10 to the 0. And we have a human farmer, right, Cam? So here's the deal, guys. I saw some people doing some great work getting exponents to be all the same here. But are these numbers actually very big numbers? No, so what I think we should do is 400 plus 120 plus 6 plus 62. So this is like the expanded answers to every one of those pieces of that expression to get 588 kilograms. So the whole point of this, here's the point of this. Here's the point of this. Scientific notation is the bomb for these really big and really small numbers, right? It actually makes things easier. When we look at this, and we have these little numbers, isn't the expanded form probably easier? So what we have now is what we call number fluency. We have like 2 tools in the tool belt or tool chest, and we pull out the right tool for the right job. So I chose to go expanded here. All right? Does that make so? You're gonna like have to make choices. What's easier where? You know, we got 8 zeros after something. You're not gonna want that. Now, just real quick, the million ants. Okay, I might actually keep that as 1 times 10 to the 6th because each ant is 3 times 10 to the negative 6. These play nice to be 3 kilograms. Right, 3 times 1 is 3. This is 10 to the 0, which is just 1. So again, that one scientific notation kind of plays nicer than having all those extra zeros, I think. All right, we're gonna stop right there, actually. And your homework is the cumulative review for the lesson.